The goal of this component is to allow the Elastic framework to migrate things from one place to another securely and reliably. So I talk about things in a fairly generic sense because serverless systems contain lots of different entities, but they're dynamic. Workloads can move around, data can move around, responsibilities can move around to different pieces of software running on different physical machines as the system has to adapt to changing conditions. An orchestrator is responsible for keeping the application functional, but this means that orchestration failures can put applications into invalid states. For example, you could duplicate a workload so that you end up with two machines running the same piece of code, or you could end up with data loss, where the source and destination machine both think the other one is responsible. Either of these are bad, and existing ways to deal with it using protocols like three-phase commit need continuously available infrastructure. So we want to try to work out how can we migrate things from one place to another without having this single point of failure and without having this single point of load where the network traffic has to go in order to facilitate these migrations. So the solution that we've looked at is optimistic fair exchange protocols. So fair exchange protocols allow two parties, here we call them source and destination, or S and D, to exchange an item between them in an atomic way, so that if the source gets their item, then the destination gets theirs, and vice versa. This was originally imagined for things like electronic transactions, so that you could, for example, buy some data, and if the seller got their money, then you were guaranteed to get a copy of the item. Now in Elastic, these items that we're interested in are what we call migration certificates. So they're a signed certificate that provides proof that an exchange has taken place, or in this case, that a migration has taken place. So the source gets proof that they are no longer responsible for a task, that the destination knows that this migration has happened, and that if they follow the protocol, then they will get this certificate that will allow them to move on and take responsibility for whatever has been migrated. And conversely, the destination gets proof that if this migration process is completed, then the sender also knows that the migration has completed, and therefore that they can safely take over the task without worrying about the task being duplicated. But the key thing here about optimistic fair exchange protocols is that in the normal case operation, they don't need any assistance from the orchestrator. The orchestrator is only needed in order to provide a certificate that ensures that the protocol aborts in the event of a failure. But if everything works fine, then just the source and destination can communicate with each other without the need for any other parties to facilitate the exchange. And this is great for performance and for avoiding points of failure. So how this fits in the architecture? Well, initially we want to integrate this with the Propeller orchestrator to confirm that orchestration processes have genuinely completed properly. And so we mark this up here in WebAssembly orchestration, but we're also interested in how this could be applied to other applications, like, for example, the key broker service or more general WebAssembly applications. And as such, we also mark it down here in WebAssembly and WASI. Ultimately, though, during the second period, this is going to be integrated into Demonstrator 2. But now let's have a look at a demo.
When designing the migration protocol, we implement two daemons on each source and destination machine. They are agent and runtime. Runtime S starts sending data to runtime D. After that, those two runtimes raise a confirmation request to agents. Agent S and Agent D continue with the fair exchange protocol. When the protocol is finished, they respond to runtimes with a certificate. After step number 4 is complete, each source and destination machine obtain a certificate of its own. There are 4 separate terminals representing daemons in our protocol design. Blue ones represent agents and orange ones represent runtimes. On the screen, the runtime D and those 2 agents are already up and running. Now the runtime S will be started with the command cargo run --bin, the name of the program, and also the path pointing to the data that we want to transfer to the destination machine. I already have a WASM component as an example. Then now both the source and the destination obtain a certificate. By having the certificate, source and destination can prove that those 2 parties follow the protocol and end successfully.
In the second period, we have a number of tasks still to complete. So first, we need to finish developing this prototype, and in particular, we need to develop the migration orchestration agent that is able to support agents to complete the protocol in the case of a failure. But then also we need to start integrating this into the Elastic framework. So first, we would like to port this migration agent to use WASI APIs to allow it to be self-hosted by Elastic. So for example, we could deploy these migration agents using Propeller. We'd also like to integrate it directly with Propeller so that Propeller can use this to ensure the reliability of its own orchestration mechanisms. But moving beyond Propeller, we would like to develop interfaces that can be used by other components to perform their own migrations, whether it's more general WASM applications, so that user applications can take advantage of this functionality, but also other parts of the Elastic framework, such as the key broker service, that have resources such as keys, where you really only want to have one copy of them floating around. And as time goes on, we'll identify opportunities to take advantage of the functionality that is being developed in this component.